Smile. Today we're going to learn how to read lines. So a lot of this information might be familiar, which is good. We just want to make sure we're all kind of on the same page. The skill that we all need to have, it's just one of the most basic skills if you're talking about linear relationships, is can you read a line? And can you take that line and describe it using something called slope? The rate of change is something that we've probably heard for a few years. And then as you move into algebraic concepts, right, and you start talking about lines, if you're describing the rate of change on a line, the word you're going to use to describe it is its slope. But just know that these kind of mean the same things. The most important thing to know if you're reading a graph is that you're going to read it just like you would read a book. So we're going to go from left to right. And as we do that, there's some things we want to know. So is the line moving up or down, right? So we're thinking, is the line positive or negative? We're also wondering by how much is it moving up or down? So we're going to assign a number to this. And we're going to call that the change in y. So this is something you'll see in math and in science as you get older. That triangle just means the change in y. And then likewise, as it's moving up, how far is it moving over? So moving from left to right. And we'll call that the change in x, right? So change in y, change in x. The ratio between the change in y and the change in x is something we would call the rate of change. So rate of change. And what that would look like is a fraction. So we'd have the change in y over the change in x. That number, so if it's like a number divided by a number, would give us something called the slope, right? And really you can say either of these words and it means the same thing. This just usually means lines, and we're talking about graphs, but again, this is interchangeable. Change in y over change in x. And sometimes you'll hear somebody say the rise over the run. So you're measuring how much is the line going up or down as we move from left to right. Okay? So let's just kind of look at some examples. And the only thing you really need to know is when you see a line, to solve for the slope of any line, we only need to identify 2 points on that line. So really the first thing we're going to practice is just can we find 2 points. And I'm going to kind of zoom in on this problem here. You'll have to excuse me, I'm kind of working off of a weird little chair setup. Thank you. Okay, so looking at this example here, it's looking like it's comparing time and distance. And as we trace our finger from left to right, we're seeing that there's a point at 0, 0, and we're just looking for a perfect intersection. So do you see how at the 8, there's a dot? Basically the 8 and the 1 are crossing like perfectly on the grid. So basically we have a 0, 0 and an 8, 1, right? And so as we move from 0, 0 to 8, 1, from left to right, the line is increasing, right? It's going up, which means its rate of change is positive, right? And so that rate of change and the slope are the same thing, so we know that it's going to have a positive slope. So all we really need to do is find the slope. So the most, I guess, consistent way of finding this in a way and getting it right is if I just make a table of x and y values. So I'm going to take my 0, 0 and my 8, 1, and all I'm going to do is solve for the change in y. So from 0 to 1, I'm adding 1. From 0 to 8, I'm adding 8. So the change is 1 over 8, right? So the slope is change in y over the change in x. From 0 to 1, I'm adding 1. From 0 to 8, I'm adding 8. And so positive 1 over positive 8 is just 1/8. So that's pretty much it. The slope of this line is 1/8. You'll notice it's positive because the line is going up. So that's just kind of one way to check your math. If we were to look at something maybe a little bit different, I'm going to fold the paper because I'm basically using a chair to prop up my camera. Let's look at something where maybe it's going down. So from here to here, right? From left to right, the line is going down. So we'd say it is decreasing, which means its rate of change is negative, right? So the first thing you're gonna do is just kind of pick out a point. Anytime there's a 0, 0, I'd use it. And then you're just looking for where does the line kind of perfectly intersect. Looks like right there. So at that 5, it looks like it's perfectly at -10. So see how these are kind of not really crossing the grid in an intersection? So I have my 2 points, give myself a visual, and I think it's really important that you follow these steps right now because the numbers will eventually get harder, and this is just gonna work every time. So 5, 10. So we're going from 0, 0 to 5, 10. So 5, 10. And that's a -10 because we're going down. And from 0 to -10, right, we are going down 10. But from 0 to 5, we're going up 5. So if I were to write my slope, right, I'm going to use my change in y over the change in x. And that's going to be down 10 over 5, right? Then when I do -10 divided by +5, I would just get a -2. So my slope could be -2. Another way to think of it would just be -2 over 1, just because anytime we have a number over 1, it's just going to stay the same, right? So you could see both. This is really helpful if you're trying to graph, because then you'd have a rise number and a run number. What would you change the y by? What would you change the x by? One thing, so I have 1/8, -2. If you flip your paper over, and actually there's like a top little part that kind of folds down, you can kind of cross these off as you go. It might be smart just to maybe do one more example. So what you could do is this. Let's just pick one, and let's look. What do we do here? So this one on the back, if you could find this problem, one thing you could do right now is just pause the video and see if you could figure this out by yourself. So is it increasing or decreasing from left to right, which means the slope is positive or negative, and then could you solve for the slope? So this would be a good time to just stop the video and then unpause it to see if your work matches mine. So this would be a good time to pause right now. And we're back. Okay, so -6, 0 is my first point, and basically as my line's moving from left to right, it's going down, which means my slope should be negative. So that's just something I want you thinking about before you start. We're gonna make a table. So -6 and 0, and then 2, -2. And you'll notice I'm always going from left to right in the order that I write the points. It just makes it a little bit easier, right? Same thing every time. So from 0 to -2, I'm going down 2. From -6 to 2, I'm going up 8. Now, this might not be something that all of us are seeing, and that's totally okay. If you wanted to, you could plug it in the calculator, right? So if I don't know what to add to -6 to make 2, right? I could just work backwards. So I could go from 2, and then I could subtract -6. So I could literally put in 2 minus -6 in my calculator, and it would give me an addition and add 8. At this point, though, we do have our change in y over our change in x, right? So -2 over +8. Now, if I were to put that in the calculator, -2 divided by 8, right, you might get, and I'm just going to kind of keep working up here, 0.25, right? Whoops. So 0.25, and that would be a -0.25, but that would be the same thing as -1 over 4, right? There's going to be a trick I can show you as far as converting fractions to decimals on your calculators, but an easy way to do that too is just if you divided this, you get your decimal, leave it this, and then what you could potentially do is check your negatives and see which decimals would match up. So -1 divided by 2, what would you get? -1 divided by 4, right? So turning these into decimals would be one way to find out which one's equivalent. But you have 3 done. Your goal is to finish the rest. And if you can do that, you're off to a great start with slope. So have fun, smile,